All right, Algebra 2 students, we're going to solve equations by factoring today. We're in section 3-4, and if you want to follow along, it's going to be on page 179 there, page 179 out of your textbook. The examples I'm giving are going to be similar to the ones in the textbook, but these are a few that I found that will help us review today. So the first thing we're going to do is they're going to give you this scenario, right? A quadratic equation in standard form with the given roots. So let's review what standard form is here. So standard form is ax squared plus bx plus c. And this, of course, is going to be your quadratic term. This is going to be your linear term. And this is going to be your constant here. So we want to get it down to something that looks like this. So let's move on to the problem and what it's going to look like. So they're just going to give you two numbers. We'll start off with 3 and -5, and those are going to be your roots. So if you were to look at it graphically, it's going to look like something like that, just a sketch of what's happening there. So, all right, so let's go ahead and set these roots equal to x and find the factors. So we're going to set them equal to 0. So we're just going to move those over to the left side. And now I have the factors. X minus 3 times x plus 5. And we're going to go ahead and set it equal to 0 and solve it using the FOIL method. So we get x squared plus 5x minus 3x minus 15 is equal to 0. We're just going to combine like terms. So x squared plus 2x minus 15 is equal to 0. And then it's now in factored form, and I just circle the answer. So let's move on to a one that's a little harder with some fractions in it. So number 2, -7/8 and 1/3. So we're going to do the same thing. We're going to set those equal to x and find our factors. X is a -7/8. X is 1/3. We're going to move them over. So x plus 7/8 equals 0. X minus 1/3 equals 0. Now, as you get better at this, you won't have to set them equal to x and move them over. You'll just know what to do, and you'll hopefully see the pattern of what's going on here. So these are the factors: x plus 7/8 times x minus 1/3, and we're going to set it equal to 0. And we're going to FOIL it just like we did the last one. X squared minus 1/3 x plus 7/8 x minus 7/24 is equal to 0. The next thing we want to do is we want to get a common denominator here so we can get whole number coefficients in standard form. So we're going to multiply this by 24. this by 24, every single term times 24. And the 0. And then we just work it out, so we get 24x squared. This becomes an 8, so minus 8x. This will become a 3. And so now we have plus 21x. And then these will cancel and become 1, so it's minus 7. And then 0 times 24 is going to be your 0 there. And then all we have to do is combine like terms. So it's going to come out to be 24x squared plus 13x minus 7. And that's equal to 0. And then all we have to do is just circle this because it's in standard form. And there's our equation that has those as the roots. So the next part is about factoring. So let's move on to that section. And we're just going to review it a little bit. So the first one we're going to look at is 3x squared is equal to 15x. And we want to set it equal to 0, so we're going to move everything over to the left side. So 3x squared minus 15x is equal to 0. And then we always look for something that's in common. There may not be something in common every time, but that's one of the things we want to look for first. And if there is, we're going to factor it out and go from there. So I see that they have an x in common, and they also have a 3 in common. So this is going to become x minus 5, and it's still equal to 0. And then I'm going to take each of these factors and set it equal to 0. So it's going to become 3x is equal to 0, x minus 5 is equal to 0. And then you just solve for x here. So we're just going to divide by 3. Well, 0 divided by anything is still 0. We're going to move the 5 over and get x equals 5. So the roots are going to be 0 and 5. So again, if you were to look at a graph, it's going to cross the x-axis at both of those points. So that's what's happening graphically. Okay, let's move on to something a little bit more complex. And we're going to look at some of the word problems. So the first thing we need to talk about is what's called consecutive integers. And so if we're just looking at a number line, consecutive integers would be like -3, -2, -1, 0, 1, 2, and 3. And they go on and on and on forever. So let's say that 0 was the first consecutive integer and I want to write a formula to find more. So I'm going to put 0 down here. Well, 0 plus what is 1? Well, that's going to be x plus 1. Well, 0 plus what is 2? So the next one is going to be x plus 2. And the pattern just keeps continuing. So those would be your consecutive integers. If you were to find 2 of them, you'd use these 2. Find 3, you'd use those 3. And to find 4 consecutive integers, you would use 4. It just keeps going. So the next thing we got to talk about is consecutive even integers. Okay, so that would be -4, -2, 0, 2, 4, and the list would just keep going. So again, we're going to start with 0 as x. So 0, Well, what do you add to 0 to get 2? 2. This is x plus 2. And then you would add 4. And then it would just keep going on to infinity there for x plus 6, x plus 8, multiples of 2. Well, let's talk about consecutive odd integers. So consecutive odd integers are a little bit different. They're not going to include 0 here, but we'll just start. We know one of the first positive odd numbers is 1, 3, 5, 7. Then we're going to have -1, -3, -5, and it's just going to keep going in both directions. So here we're going to start with x being equal to 1. So we're going to say that this is x here. Well, 1 plus what is 3. So this will be x plus 2 again, x plus 4, x plus 6. So basically the even and the odd integers have the same pattern here. So let's look at a problem and how to set it up and what you're going to encounter on your homework here. So you're going to get a problem like this. It'll say find 2 consecutive even integers with a product of 624. So they want 2 consecutive even integers, and the product of those integers is 624. So product is 624. So consecutive even integers means I'm going to define x to be the first even integer, and x plus 2 will be the second even integer. And then if they wanted more, we'd have x plus 4 and so on, but we only need 2. Okay, product means to multiply. So this is going to be x times x plus 2. Well, what does it equal? It equals 624. So we're just going to go ahead and solve that and set it equal to 0 and find the integers. So this comes out to be x squared plus 2x is equal to 624. And we're going to subtract the 624. So x squared plus 2x minus 624 is equal to 0. Okay, so we're just going to factor it like normal. So we're going to take a times c, and that's going to be 1 times a negative 624, which is a negative 624. And we could go through and solve all that and work it out, but for time's sake, I'm just going to tell you which ones work here. So that's going to be 24 and 26. So negative 624 is going to equal negative 24 and 26 would be a possibility. So if you add those, we're going to get a positive 2. So if we add these together, that's going to be positive 2. Now this is a little bit different of a problem because we have 2 values here, and we're actually going to come up with 2 answers at the end. So let's just keep going with the problem. So this is going to factor into, I'm going to move on to another page here. Okay, so we had x squared plus 2x minus 624 is equal to 0. So this is going to be x squared plus 26x minus 24x minus 624 is equal to 0. And we're just going to work it out. We're going to group these first two. I'm going to change this to addition, make this a negative, and we're going to group the last two. So we're going to take out an x here. This is going to be x times x plus 26. We're going to take out a negative 24, and it turns out to be x plus 26 inside, and it's equal to 0. And so the common factor is going to be the expression x plus 26. So if I take that out of this term here, you're going to get x and then minus, and then I'm going to get the 24 when I take it out of the next term and set it equal to 0. So one of the answers is x is 26, and the other one is x is negative 24. So this is how you're going to find out what the answer is. So remember, x is the first even integer, and x plus 2 is going to be the second even integer. So what we're going to do is we're going to sub them in and see how it works here. Oops, I have a mistake. So this should be a negative 26. This is a positive 24. Because we're going to set both of those equal to 0. So off to the side, you should have had x plus 26 is equal to 0. So x equals a negative 26. And then x minus 24 equal to 0, x equals 24. So the step I forgot was just to set the factors equal to 0 and solve for x here. So, okay, so let's sub in the negative 26 first. So it's going to be negative 26, but we have to add 2 to it, so it's going to be a negative 24. So that's one possibility for your integers. Well, let's sub in 24. So if we add 2 to 24, it's going to be a positive 26. So there's really a possibility of 2 answers here, 2 combinations that would work. So sometimes you'll run into a situation where there's 2 answers. Just be aware of that and know how to handle it. I hope this is a good review for you, and you can go ahead and work on the problems in the section.